So yesterday, or Friday, we learned how to factor if the number out front is 1. Now we're going to learn how to factor if the number out front isn't 1, okay? And we're going to learn 3 different methods of doing this. However, there's one that I consider to be the easiest or best method for you to use, and I will tell you which one that is. So our first method that we're going to be using is trial and error. This isn't the best method. The only time I'd ever do this is if your A and C only have like one factor. So for example, like 1 times 3 and 1 times 5. Like those are the only time I'd ever do that. Otherwise, you're going to be doing a lot of trial and error. So basically what we do is that we find all the factors of ax squared and all the factors of c. Then we're going to use trial and error with FOIL to find the combination that gives you the correct bx term. All that we have to do is outside and inside. Okay? So I need to find all my factors of 3x squared and 5. So 1 times 3, and these both have x's, and 1 times 5. Okay? So I need to try different combinations. So I'm going to try 1x and 1, and they're both positive, so my terms are going to be positive, positive. So 1x plus 1, and then I'm going to try 3x and 5. Okay, because I know 1 times 5 would be 5, and I know 1 times 3 would be 3, so that's what gives me my first terms. Now we have to just do outside and inside. So 1x times 5 would be 5x, and 1 times 3x would be 3x, and that would equal 8x. Does that equal 16? No, so this is not an answer. So I need to try the other way, where my 3x goes with my 1, and my 1x goes with my 5. So I'm switching my x's. Okay, now let's do outside, inside. So 3x times 5 would be 15x, and 1 times 1x would be 1x, and that would equal 16x. So that one works. So my binomials would be 3x plus 1 and x plus 5. So again, trial and error is not the best method. However, these numbers would like 3, 5, 7 would be the only time that I would ever do this method, is because there's not that many options. But once you get higher than that, then there's all different things, and maybe even 2. There's only 1 times 2 equals 2. But once you get anything else other than that, there's a lot of things that it could be. Like for example, here I have 6x squared, which could be 1 times 6 and 2 times 3. So I'm going to have to try a lot of different methods. And then also I have to find 2, so that's going to be 1 times 2. And I know that I'm going to have a positive and a negative. So I'm also going to have to work with that, because I have a negative number here. So I know I'm going to have a positive and a negative. So let's just try it out. So 1 and 1, let's just do that way first, and let's do the positive. So 1x plus 1 and 6x minus 2. So that will give me that would be negative 2x, and my inside would give me positive 6x, which would be 4x. Does that work? Does it give me negative 11? No. Okay, so let's just switch our x's. So I'm going to have 6x plus 1 and 1x minus 2. So we'll get negative 12x and then plus 1x, which would be negative 11x. That's just happen chance that I got the correct answer then, because there's technically 4 combinations with the first one and then 4 more combinations with the second set of numbers. So that would be, technically, you could do 8 different trial and errors. So that's why trial and error is not necessarily the best method. However, sometimes some people just see the numbers in their brain. I can't do that. Alright, so the next method that we're going to be using is called the fraction method. Okay. Can I erase this? Okay. The fraction method is the method that I highly suggest you using the most, okay? Because it is the method that they're probably going to have on the EOC, and as well as it uses our x squared plus bx factoring that we learned on Friday, which I feel like you're pretty strong on. Okay, so the first step is we're going to be multiplying a times c. So that's the number that's out front times the number at the end. We're going to then replace c with that number and make the coefficient of a term 1. Okay, then we're going to factor like we used to factor, how we factored on Friday. Okay, then after I factor, I'm going to put the original a term as a coefficient, or as the denominator in the second part of each parenthesis, okay? Then I'm going to simplify my fractions, and then I'm going to make the denominator the coefficient in the first part of each parenthesis, and the numerator the second part of each parenthesis. I know it sounds confusing, however, when we practice it, you'll get it, okay? So my first step is going to be to multiply a times c. So that's 3 times 5, which is 15. I'm going to replace c with 15 and make a 1. Now this looks exactly like what we were doing on Friday. So now I'm going to factor just like I was doing on Friday. So if you find two numbers that multiply together equal 15 but add together equal 16, I have positive, positive, so my signs are going to be positive and positive. 1 times 15 is 15, and 1 plus 15 is 16. So I'm going to have x plus 1 and x plus 15. This is exactly the same as Friday. Now this is the part that's a little different. I'm going to take my original a. I'm going to make it a denominator in the second part of each parenthesis. Okay? So you should be writing this down. So now that I made my original a, the denominator in the second part of each parenthesis, I'm going to simplify my fractions. Can 1/3 simplify? No. So that's still going to be x plus 1/3. Can 15 over 3 simplify to 5 over 1? I'm putting the 1 there. Later on you don't have to put the 1. I'm just going to show you why. Okay, now I'm going to take my denominators and they're going to become the coefficient, so the number in front of x. And then my numerators stay there. So this is going to become 3x plus 1. Do I need to put a 1 in front of x? No, so it's just going to be x plus 5. So if you reduce and it becomes a whole number like 5, you don't have to use the denominator. And then this is my answer. The more and more you practice this, the easier it's going to get. Okay? All it is steps. None of it's hard. There's just steps that you have to follow. Okay? All of us can multiply. All of us can reduce fractions. And all of us can move terms. You can do that. I know you can. Alright, so we're going to be multiplying a times c. So that's going to be 12. I'm going to replace c with 12. And make a 1. So this is just factoring like we were factoring beforehand. So I have a negative, negative. So what do my signs have to be? Positive, negative. Because in order for me, my larger term has to be negative. Okay? You have to have one of each, and my larger has to be negative. So 1 times 12 is 12. Positive 1 plus negative 12 would be negative 11. So I'm going to have x plus 1 and x minus 12. So now I'm going to take my original A and make it my denominator in the second part of each parenthesis. So that's going to be x plus 1, 6, and x minus 12, 6. Okay, then I'm going to reduce. So can I reduce 1, 6?
No.
No. Can I reduce negative 12 over 6?
Yeah.
Yeah, to 2. Then I'm going to make my denominator my coefficient, the number in front of x. So that's becomes 6x plus 1 and x minus 2. And that's my answer. So this just has steps that you need to follow, and we're using the factoring that we used beforehand. Okay? So I suggest using this method. However, there's another method that we're going to be using, which is called the box method. If you are good at finding GCFs and you like doing that, the box method might be for you. Okay? However, I feel like the fraction method is a safer method to use. Okay? Because you might find the wrong GCF. Can I erase? Does anybody still need this? Yes.
What would happen if the first number wasn't 1?
What do you mean?
Like if it was like 18 over 6, then when we simplify, would we have x plus 3?
Yes, you're gonna have two. I'm gonna show you one of those in the following. You will have two numbers that you move up. Okay, and there is one that is like that I will show you. Okay. All right, well I'll show you the box method now. So the box method, we're still going to multiply A times C. But then we're going to factor AC. Okay, we're going to find two numbers that multiply together to equal AC, but add together to equal B. Okay, just like we were doing. But now we're going to replace that B term with those two numbers. Okay, because it will add up together to equal B, so all that we're doing is changing B. Then I'm going to make a tic-tac-toe board and I'm going to place all four terms in the boxes on the bottom right. Okay, kind of like a Punnett square in science. Then we're going to take out the GCFs for each column and each row. So there's going to be 4 that we pull out. Then we're going to write our answer as a product of the GCFs. Okay? So I'm first going to multiply A times C. So that's going to give me 15. I need to find two numbers that multiply together equal positive 15, but add together to equal 16. So that's going to be positive and positive, and that's going to be 1 and 15. So all that we were doing is replacing 16x with 1x and 15x, because 1x plus 15x is 16x, and it's not changing my problem at all. So I'm still going to have my 3x squared plus 1x plus 15x plus 5. Okay? Then I'm going to make a tic-tac-toe board. In the bottom right down here, I'm going to take each one of these terms and place it in there. Okay? I'm going to have 3x squared, 1x, 15x, and 5. Then I'm going to find the GCF of each column and each row. Okay? So what can go into 3 and 15 evenly? 3. 5 can't go into 3. What about x squared and x? X. Okay, so that's my GCF there. How about 1 and 5? 1. Is there an x in both?
No.
So it's just 1. Okay, how about 3 and 1? 1, x squared and x?
Yes.
X. 15 and 5? 5. Is there an x? No. So one of my parentheses is going to be 3x plus 1, and the other parenthesis is going to be x plus 5. So it's this one and this one. However, if you pull out the wrong GCF, then you can mess up the whole thing. That's the reason why sometimes the box method is not the best method. Okay, because you can mess up your GCFs. Okay, like if he accidentally put 5, and then that whole messes up the whole thing. Not saying that's why the fraction method is the preferred method. So I'm gonna first multiply a times c, because I still have to multiply a times c, and I still have to do finding b. So you're not really doing much shorter, you're not doing much shorter. So that's gonna give me, technically negative 12. Negative 12. So I'm gonna have to and what is it, positive, negative, right? So my larger number has to be negative. 1 times 12 is 12, and 1 plus negative 12 would be negative 11. And I'm only doing the first term, 1 and otherwise sometimes you're going to have to factor out many of them. Okay, because right now we're just doing 1. So I'm going to replace negative 11 with positive 1x and negative 12x. So 6x, then that would be positive 1x, negative 12x, and negative 2. Because positive 1x plus negative 12x is going to give me negative 11x. So we didn't change our problem at all. I'm going to take my tic-tac-toe board and write out each one of these terms. So 6x squared, 1x, negative 12x, and negative 2. Okay, what is my GCF of 6x squared and negative 12x? No, that's not the largest. 6x, right? Because a 6 can go to 6 and a 6 can go to 12. So I would use this method if you're not good at finding GCFs. How about 1x and negative 2x? 1. How about 6x squared and 1x? 1x or x. Negative 12x and negative 2. Negative 2. Okay, and because both of those are negative, I can pull out a negative. So that's where my negative is going to come from. So I'm going to have 6x plus 1, that's both positive, and x minus 2, because of my negative. So these we can use any method of factoring. I'm going to show the fraction method on the first one, and then I'll let you guys pick. Because I want to. Can you please stop doing that? Thank you. I'd like to show you guys what happens if we don't reduce and it doesn't equal 1. Okay. So our first step is going to be multiplying a times c. So 10 times 6 would be 60. I'm going to replace x squared, 10x squared with x squared. 17x is still to be there, and then we'll replace 6 with 60, the a times c. Okay? Now I'm going to factor with normal. I have a positive, positive, so my signs are going to be positive, positive. And then I'm trying to find numbers that multiply together equal 60. So 1 times 60, 2 times 30, these don't add up to 17. 3 times 20, 4 times 15, getting close. 5 times 12. Yeah, 5 times 12 is 60, and 5 plus 12 is 17. So I'm going to have x plus 5 and x plus 12. Okay? Then I'm going to take my original a and make it my denominator. So I'm going to have x plus 5 over 10 and x plus 12 over 10. Then I'm going to reduce. What does 5 over 10 reduce to? 1/2. And what is 12 over 10 reduced to? 6/5. Okay? Then I'm going to take my denominators and make them the coefficients, the numbers in front of x. So this is going to become 2x plus 1 and 5x plus 6. So if you have two denominators, they both get moved up, okay, into that parenthesis. Madison, did that answer that question?
Yeah. Also, like, for the first x plus, like, 1/2, what if it was, like, backwards and, like, the 6 over 5 would be in the first one?
That doesn't matter. The order here doesn't matter.
Okay. But what if neither of them equal 1? Like how there's like 1/2 and there's like a 1 on top?
Yeah, but that 1 could have been a 2/3.
Okay, and it wouldn't matter?
It wouldn't matter. The 3 would just stay there instead of the 1. Okay? The numerator is always the second number. The denominator is always going to be the number in front of x. Okay? After you reduce. Alright, which method would you guys like to use here? Box method? Alright, so we still have to multiply a times c, which would be 132. Then I need to find numbers that multiply together to equal 132 but add together equal negative 37. So I have a negative and a negative, correct?
Yes.
So 1 times 132, now 2 times 66, now 3 times 44, now 4 times 33. Yep. So I'm going to replace negative 37x with negative 4x and negative 33x. Okay, then I'm going to create a tic-tac-toe board and list out each one of my terms. So I have 3x squared, negative 4x, negative 33x, and 44. Okay. Now I need to pull out my factors. So what can I pull out here? 3x. What can I pull out here? 4. How about here? An x. And here? Okay, and we know both of them are going to be negative though. So this is why the box method is a little confusing here, because I didn't have the 2 negatives to pull out. But we know that it's negative, negative, correct? So that's why sometimes the box method can get confusing, because I couldn't pull out a negative out of both. Even though there are 2 negatives. So I'm going to have 3x minus 4 and x minus 11. I guess if I pulled out a negative 11, that would make it, but not, it would make the other one negative then, and that would be confusing. So that's why sometimes the box method isn't good to use on problems like this, because otherwise you're going to be confused by your signs. Okay? All right, let's try the next one. Can I erase this? All right. So some things to remember, none of your questions on your homework are going to be like this, but later on Friday we're going to be teaching you like all methods. You can't forget the things that we previously learned, okay? And on Friday I'm going to talk about this. The first thing that we always need to do is look for the GCF to see if there is a GCF. In this first problem here, there is a GCF, 3. 3 can go into each one of these numbers, so I have to pull that out first. You're not going to have one like this on the homework though. So remember when we pull out our GCF, the GCF goes on the outside? And then I divide each term. So this is going to become 2x squared minus 7x minus 3. Now I'm going to factor this. Okay? So I'm going to multiply a times c and get negative 6 and then negative 7x and then x squared. And then I'm going to find 2 numbers that multiply together equal negative 6 to add together to equal negative 7. So what are my signs going to have to be? Positive, negative. So 1 times 6 is 6. 1 plus negative 6 would be negative 5. So that doesn't equal negative 7. How about 2 times 3? That would be negative 1. Does anything work here? No. So it's considered prime. It's considered prime after you get to that point, because technically it wasn't prime because I was able to pull out a GCF. But you won't have one like this on the homework, okay? So don't stress out too much. We will be getting things like this. Alright, there isn't a GCF here, so I don't need to worry about that. What method would you guys like to use here? I prefer to use the fraction method, so we can practice that. Let's just use that. Okay, so multiply a times c. So that's gonna be 20. So x squared plus 19x minus 20. Okay, so I have a positive, negative. So what are our signs gonna be? Negative, positive, and I'm looking for 20. So 1 times 20, and that is 19. So that's gonna be x minus 1 and x plus 20. Then I take my original a and make it my denominator. And then reduce. So this one cannot reduce, but this can. Then my denominator becomes my coefficient. 2x minus 1 and x plus 10.